For most of human history, Mars was nothing more than a distant red dot in the night sky. But in 1971, humanity finally reached it. The first spacecraft to successfully land on Mars was not American, it was Soviet. The mission was called Mars 3, and it achieved the first soft landing ever attempted on the red planet. Attached to the lander was a tiny experimental rover known as Prop M. It was incredibly small, only about 21 centimeters long and weighing just over 4 kilograms. Instead of wheels, it moved using flat ski-like legs that allowed it to slowly step across the surface while connected to the lander by a power cable. Its job was simple: test the strength and density of Martian soil. Unfortunately, only 14 seconds after landing, the signal disappeared. The lander went silent, transmitting just a single distorted black-and-white image before communication was permanently lost. The Prop M rover never even had the chance to deploy. Still, Mars 3 proved something historic. Landing on Mars was possible. A few years later, NASA followed with the Viking missions in 1976. Viking 1 and Viking 2 carried advanced scientific instruments and became the first missions to send detailed photographs from the Martian surface. For the first time, humanity saw Mars not as a blurry telescope image, but as a real landscape: rocks, hills, and a dusty orange sky. But these landers had a limitation. They could only study the ground directly beneath them. Mars is an entire planet, and examining a single spot was like scooping one handful of sand from a desert and expecting to understand it completely. NASA realized something important. To truly explore Mars, the machines would need to move. That idea finally became reality in 1996 with the Mars Pathfinder mission. When the spacecraft landed, it opened like a mechanical flower, and from inside rolled out a small six-wheeled rover named Sojourner. For the first time in history, humans were driving a vehicle on another planet. Sojourner was about the size of a microwave oven and used a revolutionary suspension system called the rocker bogie. This design allowed each wheel to stay in contact with the ground while climbing rocks in uneven terrain, critical on a world covered in sharp stones. Its job was simple: test the strength and density of Martian soil. Communication with Earth only happened once per day. Scientists would send instructions and then wait until the next day to see what the rover actually did. In 3 months, Sojourner traveled only about 100 meters, but that small distance changed planetary science forever. NASA now knew mobile exploration worked. In 2003, NASA took the next major step with 2 larger rovers, Spirit and Opportunity. These were far more advanced, about the size of golf carts, and carried full laboratories of instruments. Each rover had multiple cameras mounted on a tall mast, giving them a human-like viewpoint of the landscape. They studied rocks, searched for water evidence, and sent back thousands of images. Spirit operated for 6 years. Opportunity exceeded all expectations, surviving over 14 years and traveling nearly 45 kilometers before a massive dust storm finally ended the mission. Mars was no longer a mystery world. It was becoming a place we understood. Then came a giant leap forward. In 2012, NASA landed Curiosity using the incredibly complex Sky Crane maneuver, a rocket-powered platform that lowered the rover to the surface using cables. Curiosity was enormous compared to previous rovers, about the size of a small car. Instead of solar panels, it used a nuclear power source that converts heat from radioactive decay into electricity. This allowed the rover to operate day and night and survive freezing Martian winters. Curiosity's mission was clear: determine whether Mars ever had conditions suitable for life. And the answer was yes. Evidence showed ancient Mars once had rivers, lakes, and possibly oceans. In 2021, NASA sent its most advanced rover yet, Perseverance. This rover carried 19 cameras, microphones, and new scientific tools. For the first time, we didn't just see Mars, we heard it. The wind moving across the planet, the wheels crunching on rocks, even the mechanical sounds of a robot working millions of kilometers away. But Perseverance brought something even more revolutionary. Hidden beneath the rover was a small helicopter named Ingenuity. Many scientists doubted it would even fly. Mars has less than 1% of Earth's atmospheric density. The air is incredibly thin. Yet in April 2021, Ingenuity lifted off the ground and made the first powered flight on another planet. It was a Wright brothers moment, but on Mars. Originally designed for only 5 flights, Ingenuity completed 72 flights over 3 years. Humanity had just added a new method of planetary exploration, aerial exploration. Now, NASA is planning future flying explorers, capable of traveling kilometers in a single day, collecting samples and mapping terrain far faster than any rover could. And this technology won't stop at Mars. A mission called Dragonfly will send a drone to Saturn's moon, Titan, a strange world filled with rivers and lakes of liquid methane beneath an orange sky. Mars taught us how to drive on another world. Now it's teaching us how to fly. And once we master flight beyond Earth, the exploration of the solar system will truly begin.